Hi everyone. In last class we have discussed about the PN junction diodes. In this video we are going to discuss about the rectifiers. Here we are going to learn what is rectifier, why it is used, where it is used, and types of rectifiers. First of all, we will know the definition of the rectifier. Rectifier is an electric device that converts an alternating current into a direct current by using one or more PN junction diode. Here the use of this rectifier is converting AC current to DC current. What is the application of this? Let know. One of the most important application of the PN junction diode is the rectification of AC to DC. Here AC current it will rectify to DC. In detail we are going to learn here. And PN junction diode allows electric current in only forward bias condition and blocks electric current in reverse bias condition. Here we know that we have learned about this forward and reverse bias. In this rectifier, for the rectification purpose, we are using this PN junction diode to convert AC to DC. Here we were having only one diode in this rectifier. It will convert AC to DC, but one more thing is, an PN junction diode allows electric current in only forward bias condition and blocks electric current in the reverse bias. It allows only the AC current in forward bias only. When it allows forward bias, it will block the it will block the reverse bias condition. When the current is flowing in this reverse bias, it will blocks the forward bias condition. Like in simple words, here we have written that a diode allows electric current in only one direction. You know that diode acts like an rectifier. Okay, we know that in our houses we are getting the AC current, right? But some electronics devices like laptops, mobiles, we need that DC current. So in like these laptops and everything, we need DC current. So with that help of this rectifier, it will converting the AC current to DC. Here we were having two types of rectifiers, half wave rectifier and full wave rectifier. Let's know about this half wave rectifier. It is an name in this name suggests that the half wave rectifier is a type of rectifier which converts half of the AC input signals, that means positive half cycle, into a DC output signal, and the remaining half signal, negative half cycle, is blocked or lost. Here the current it will convert the AC to DC in only one positive half cycle. In negative half cycle, it won't allow the current to flow. It will block the current. In half wave rectifier circuit, we use only a single diode. So this is the purpose of blockage of another half cycle. In positive half cycle, we will give the one diode, so it will flow towards that forward bias. The another cycle will be blocked. This is the simplest way to understand. This is the AC current flowing towards this PN junction diode, which means half wave rectifier. The output will get in DC. Here we are going to learn in simplest way that this is the half wave rectifier diagram. This is the AC current. This is transformer, and these are primary and secondary windings. Here we have taken only one diode. This is a half wave rectifier, so here we were having only one diode, and this is load. When the input current is flows toward this transformer will reduce the voltages. Like if this input having 130 to 230 volt AC current, when coming to the secondary stage, the transformer will convert it into 12 volt AC, not DC, AC. From this 12 volt AC, it will flow towards this forward bias in this PN junction diode, and it will convert into AC. Here we will get the AC current, AC voltage, sorry. This is all about this half wave rectifier. Let's go to this full wave rectifier. In this full wave rectifier, we know that in half wave rectifier current flows only in this forward bias. It will block in this reverse bias. Here what happens is it will flow in both the directions, in forward bias and reverse bias. Let's see how it will happen. The full wave rectifier is a type of rectifier which converts the full AC input signal, positive and negative half cycle, to pulsating DC output signal. Yeah, we know that the efficiency of the full wave rectifier is higher compared to half wave rectifier. Why? Because here we are the current flows in this two biases, forward and reverse biases. This is D1, this is D2, this is RL load, and in this center part is called center tap. We can see this only in this full wave rectifier. Yes, you can note it down in detail in this paragraph. And one more thing, in full wave rectifier we were having two types of rectifiers. One is 2 diode rectifier, one more is 4 diode rectifier, which is also called as bridge rectifier. Let's get to know about this bridge rectifier. During the positive half cycle of the AC input voltage, D1 and D2 are forward bias conducting, and D3, D4 are reverse bias. These are non-conducting. Same as in during negative half cycle, D1, D3 and D4 becomes forward bias. D1, D3 and D4 becomes forward bias. In negative half cycle, D1, D2 become reverse bias again. At the result, what we are going to get is this process. The output voltage across the load is always positive with respect to the ground. Efficiency converting the AC input into a pulsating DC output. To get smoother output in this bridge rectifier or a full wave rectifier, if we add capacitor, what will happen means, to get smoother output, a capacitor is connected to the load, which helps to reduce the ripple voltage, resulting in a more stable output. See, if we add capacitor means we will get the smoother output with more stable DC output. This is all about this bridge rectifier.